Brilliant. Well, thanks again for joining. It's wonderful to see people here in this department and colleagues joining online from multiple countries around the world. And really pleased to have Lorenzo Miani joining us today, who, despite, in his words, being vegan and not drinking coffee, is Italian and is joining us from Italy, and joining us for this ETC Hub seminar, so the Education and Training for the Climate Hub, that's been trying to bring together some interesting interdisciplinary conversations around climate change education. I'm really pleased to have Lorenzo here talking about the role of uncertainty in dealing with extreme events in climate change education. We'd schedule in until 1, and we'll definitely have time for kind of conversation and questions and so on. So please do, if you're online, use the chat, and then there'll be a chance to kind of unmute and videos and so on later. But please feel free to use that kind of whilst we go on as well. Otherwise, over to you, Lorenzo.
Right. Thank you. The really kind introduction. So, hi people online, hello everybody here. My name is Lorenzo Miani, and as Steven said, I'm a PhD student at the University of Bologna, and I come from physics. So, right here, okay. So I come from University of Bologna. I come from the Department of Physics, and I'm like in physics education field already since 4 or 5 years, let's say. But I started to focus on climate change education since I started my PhD already 2.5 years in a way. This is like my research group. I think you can see a familiar face here. This was taken from the project Fedora, because University of Oxford, University of Bologna already collaborated together, like many activities. And my supervisor is Professor Olivia Lebrini. She works in the field since like many years now. So like this is my ward, and of course like this is the wonderful city of Bologna, as you can see, my department. That matches like the beautiful of Oxford actually. Almost there. All right. So as we know, I don't think I have to stress this enough, but there are like from outside? All right, okay, construction. I mean, we know how much climate change is important nowadays, and we know how much climate change education is fundamental to bring students like to first like create interest into the topic. They already have a lot, but you know we need more in schools. There are many issues in the climate change education field, like in the literature, mostly connected to like the problems and issues that students have with thinking about the future. There is also climate anxiety towards like the vision of futures, and there is like a lot of difficulty in actually grasping the inner complexity and uncertainty that is rooted in climate. We know that climate can be addressed as a complex system, and coming from physics, we think that a science education approach to climate change can actually offer a lot of instruments to deal and navigate this complexity. So the main research questions of my PhD project are mostly connected to this two here. So how can an approach called future-oriented science education, that was like the framework that we developed in the Fedora project, so like to think about science education, but with the aim of giving students the instruments to think about their future, to envision different futures. So how can this approach can be used to address the study of climate change through the concept of uncertainty? Because uncertainty is a really big part, and I will tell about it later. And also, to what extent can an uncertainty-centered course on climate change develop sustainability competencies? All right. So today I will talk about first of the theoretical background on my PhD project. Is that all right? Yeah. Okay. I'll first talk about the theoretical framework that is behind my project, and then I'll talk about the main part of my project that has been an implementation of a course that we designed and implemented in Bologna like 6 months ago now. And then I'll talk also about the data analysis part that I did. Maybe I didn't say that. Why in Oxford now? I'm a visiting PhD student, and I did like a bit of a tour around the UK. So I've been for some week at UCL working with the Center for Climate Change and Sustainability Education. And then I spent the last almost 3 months at the University of Southampton working with Dr. William Park on how to, let's say, connect my vision with this vision. He works on disaster education. He was a DPhil here in Oxford with Professor Sibella Duran, and now he's focusing on disaster education. So later, I'm also going to talk about how we try to bridge like my vision and his work. So the theoretical framework. All right, so, okay. So basically, there are three main parts of my project, like the framework, that are like the sustainability, uncertainty, and future studies. Of course, sustainability is like, we can say it assumes a foundational role. So like it's really the basic, or like what are the values, what are the like the vision we want to implement. Uncertainty is used as a fundamental topic coming from physics to address the problem of climate change. And future studies as used like to offer tools to get students to look at their future, all right? So I'm just going to throw it quickly. So for the sustainability part, we use as a reference GreenComp. GreenComp is a sustainability framework, competence framework that was built from the European Commission 2022, so just at the very start of my PhD. And it aligned with all, let's say, our idea of what sustainability should be. So there are four main areas in GreenComp that are like the values, the complexity, action, and futures. So it's really close like to our vision. And we tried like to, when I say we, like, because I talk about myself, but also about my research group, is always a collective work. It's not just myself. So I always use like the we. And we tried to address GreenComp, to use it as a, let's say, as a skeleton for our work. About uncertainty, we are trying to develop this kind of conversation about the concept of uncertainty and how uncertainty is fundamental for our, let's say, vision of science, what science is today. So we distinguish between four layers of uncertainty. So the deeper level, we can say that uncertainty can be treated as a main topic. So like we need to learn what uncertainty is. We need to learn like how through uncertainty, like how science works, all right? We need to think about uncertainty, like to actually develop a probabilistic thinking, and then how to use uncertainty to learn how to inhabit and act in our society. So you can see like there are four levels, you know, like comes from the mere content to like how uncertainty is actually connected to our society. And I mean, like, for example, when you talk about learning uncertainty, we can talk about the theory of measurement, or like statistic, probability, Heisenberg principle, like all these things that are deeply rooted for sure in physics, but in every field of science. Then when we talk about like how science works, we can see how uncertainty makes science advance and how science deals with uncertainty in its like epistemic practices. Then when you think about developing a probabilistic thinking, we can think about like how uncertainty can actually help us to be open to new evidences, like to account for what is already known, to consider also alternative explanations. And when you think about risk and how to actually like live in our society, uncertainty is fundamental. Because of course, when we talk about risk, we need to think about things that may happen or may not, but we need to be prepared. So it's really fundamental. And also like when you think about climate change, we can see like all the issues connected to climate change as weak problems. So when you have to deal with weak problems, we don't have any kind of certainty. So we need to use uncertainty. Then, in particular, in my work, we distinguish between three different typologies of uncertainty, with types of uncertainty. And this framework actually comes from mainly like an approach developed by Professor Shepard, that is at University of Reading. So they distinguish between three types of uncertainty. That is the aleatoric uncertainty, so the uncertainty connected to like the mere complexity of climate as a system. So it's connected to the internal variability. Epistemic uncertainty is mostly connected to our way of understanding the problem. So how far science went to like grasp the proper, like deep, like the knowledge we have on the climate. And reflexive uncertainty is the uncertainty that we have towards how people will behave in the future. So like how people will manage. Like they will face, I don't know, an extreme event, for example, or like to think about their own future. We don't know that. So like these three different types of uncertainty are really useful because they can actually make us understand what kind of things we can act upon, what is like the uncertainty that can be reduced, and what is the uncertainty that cannot be reduced but must take into account. So for example, we cannot reduce the aleatoric uncertainty or complexity of a complex system because it's rooted into the system. So we cannot change that, but we can make like statistics, like to learn how frequent, for example, an earthquake can be. We can actually, for sure, we can work on our ability or our capability to learn about systems, so like epistemic uncertainty, but like also like for reflexive uncertainty, we cannot reduce it because like something connected to the future, so we don't know, but we can make like scenarios, like to see how things like may go on. Then talking about futures, we use like the tools that come from the future studies. So for example, the futures cone from Boris, I think it's a famous tool that you can use. And the main part of this tool is that it can make like students, for example, distinguish between different types of future. So like to distinguish between what is like all like the possible things that can actually happen. Then there is like the plausible, and then there is like the probable and the preferable. So like learning to distinguish like between these different types of future can actually give students the ability to understand what are their possibilities. So to distinguish between how they see their own future and what kind of future they want, all right? So it is an important part that also in this framework, we introduce the concept of wildcards. So things that can actually happen and we cannot predict. So like low probability events that may have high impacts. The connection with extreme events is really it's really easy to make when we come from this framework, and I will talk about that in a bit. So in my PhD, I started from the study of extreme events, and then from there, we developed all this discussion on uncertainty. From uncertainty, we developed a course for secondary school students, and I'm now going to talk about the course. So we had 34, like 12 or 13th grade students coming from secondary schools surrounding University of Bologna. They were coming to the university, so they were coming in the university because we have this system where basically they have to fulfill some like hours, like to do courses to orient themselves towards university because they were like approaching university. So we gave them this opportunity. The course was like structured like this, so like 6 main lessons of 3 hours each, and then a final restitution of 2 hours. And we use it, of course, both as a course, but also as a research environment. So we collected data before, like the start of the course, during, and at the end of the course, through questionnaires. Yeah.
So we have one comment from Zoom, which is the further you get from the podium, the harder it is to hear.
Oh, okay, sorry. All right, thank you. I started to take close. Yeah, all right. Okay, so we gave them questionnaires like during the course, and then we made some interviews after the course with those students that wanted to participate in the interviewing process. And I'm gonna talk about later. So we started from an introduction to climate change. We focused on the concept of uncertainties in physics. Then we talk about uncertainties in climate change, addressing extreme events and all the connection with IPCC. Then we moved on to the fields of future studies and shared socioeconomic pathways, so SSPs, so how the IPCC creates their own scenarios. We discussed this scenario representation with them, and then we focused on how to implement the whole decision-making process connected to climate change. And I'm going to talk about that in a bit. And then we had a final restitution, because as a final activity, we created a game board that connected all the areas of the course. So it was really focused on our activities. So the learning goals of the course were connected to 3, let's say, main areas. So like from the knowledge about climate change, of course, we wanted them to know and recognize the main aspects of climate change, distinguishing between climate change and like meteorological phenomena, so like climate and weather, to understand also the different types of uncertainties that are related to physics and climate change. Connected to the future, we wanted them to learn and use the tools offered by the future studies, so like the distinguishing between the different types of future, and also to get acquainted with SSPs to like also reason on the feasibility and implications of different future scenarios. What does it mean to have different possibilities? And then from like more science, policy, and action area, let's say, we wanted them to understand the relationship between science and policy, so like behind the whole IPCC process, and to develop sustainability competencies, to recognize the complexity of the decision-making process, climate change, and also to think about what are like the possible activities, you know, like how they could act towards the problem. So it's really broad, I know that, but you know, like it was really a long work, and I did all of this together, of course, with our research group, and in particular with another colleague of mine, Francesco De Zuani Cassina. He's also a PhD in University of Bologna, and he's now like finishing. He's visiting University of Copenhagen, and he focuses more on the identity part of science. So we did this whole course together, and when I talk about we, I also mean him. So here, with this really colorful graph, we can see how different layers of uncertainty that I explained before were structured throughout the course. So we can see that we started with uncertainties of content, like the first lessons, and then we moved to uncertainties as an interdisciplinary environment to think about also like how uncertainty can actually work as a scenario builder, and how uncertainties can be seen as a space for action, all right? How did we think about the space for action? And as I told before, we created a game board, all right? So in this game board, we tried to put everything together in our course. So I'll try to show you here. So we had different sectors where students could actually work on. And this game board is connected to a simulator from MIT, the N-word simulator, where basically students could work on all those slides that you can see there, and to change the projection, you know, like towards what kind of temperature they will reach if we act in a certain way. The simulator goes on until 2100. So we created our game to go from today until 2100, going through two steps, so like 2030 and 2050. And students worked in groups, and each group had like an expert for each field, and they tried to create like, you know, their scenarios to actually reach those kind of goals. The game was really interesting, and we basically created it like while we were doing the course. So it was really like, you know, a last time gig, but it was really interesting to see how they worked on it, and also the kind of, let's say, strategies they thought about to reach the goals. And maybe you can ask like why, you know, how uncertainty was connected to this, because you talk about a lot of uncertainties. So you can see here, there is a small space for wildcards. So literally wildcards. So we created wildcards with them. So basically, we created like these different categories of aleatoric uncertainty cards, reflexive uncertainty, and epistemic uncertainties. And we gave them like an idea, like in the 5th lesson, we gave them like an idea of what kind of wildcards we would like to create. And then each group created a pair of them. And then all together, we decided on which one to use in the course. So we came up with 16 in the end. And each group had to, for each turn, for like, you know, until 2030, they had to draw like 3 cards. So they could like, they had to work on this kind of events. And they're really like, you know, different between them. There are some that are connected to the aspect of society, some things that are connected to like external events, and they had to react. And each of these cards was connected to the sliders of the simulator. So, you know, they would to like change the kind of space of action they had, all right? So, as I said before, we gave them some questionnaires All right. So we asked them how extreme events and climate change. Actually, we just asked them how their life was connected to climate change, how they saw climate change affecting their life. We asked them this at the first lesson and in the last lesson. And then during the course, we asked them some question about the future. So what is your image of future into 25 years from now? What is your image of ideal future 25 years from now? How do you think we can actually achieve that future? And what kind of emotion do you have like with respect to that future, right? Then at the end of the course, we asked them if they wanted to participate in this round of interviews, and 9 students out of 34, so like almost 1/3, accepted. So we created like this really long semi-structured interviews of almost 1.5 hours each, sometimes also 2 hours, where we went through all those areas. So like we started from why they decided to come to our course, what kind of relation they had with climate change and sustainability in general, which were their visions of futures, what kind of like relation they had with uncertainties, what kind of reaction they had to the game, and what kind of impact the course had on their ideas, and finally the personal relation with science. So like many things we asked them. It was like a really nice conversation. They were like 9 amazing interviews. And so basically what they did in the last months, so we finished like the interviewing, like the interviews, we finished them start of January. So like from January until now, we proceeded with the analysis of the data. And I did this partly also with Professor Park in Southampton. So I'll explain that later. So we focus in particular on 3 specific research questions. So in what way students perceive climate change and which were the most relevant aspects for them about climate change? How do students react to the use of uncertainty to address climate change? And what was the impact of the course in the relation between science and policymaking for them? So something that came up really quickly was that when they thought about climate change, they were thinking about extreme events. So when we asked them how climate change affects your life, your daily life, they almost like more than half talk about extreme events. So like part of the people that were like attending the course went through the big flood that we had in May. So it was like really close to Bologna, and they still had like the all the memories in them. So it was really there. Then the other biggest part focused on like the changes in temperature and weather. Like the summer is really hot and like the winter is really cold. But it was like some sort of naive approach. So like they were almost focusing on like weather changes, not just climate changes. So like this morning was really cold and now it's really hot. Okay. And then some human activities connected to pollution, recycling, and these kind of things. So it was really interesting to see their reaction to extreme events. So when they were talking about the impact of extreme events, they were using like words as it opened the eyes of many to the need to address the issue of climate change. So like open the eyes. It made me realize how devastating these events are and how dramatically they are becoming more and more frequent. Like impressive events make you realize how destructive climate change. So basically, these kind of events open the eyes. They make them understand the severity of the problem. All right. This comes from the questionnaires. So like the first and last lesson, let's say. And we received almost like the same kind of information also through the interviews, but way more detailed. So regarding extreme events, they were like using this kind of words. So like for example, the first one says, we talk a lot about it, but not as if it were something that is happening, but where and how we do not know. But now we have seen it has happened, and so in that sense, we're all involved. All right. Or also, I realized that there was a problem there, and that it had for the first time had an effect on my life. Okay.
It's just a test.
Yeah. And they were thinking about these extreme events as something that actually make them understand the severity of the problem and how much short time we have to act on it, and also it make them feel not secure anymore. This relation between something that was distant, but now we also went through it. So it was really interesting. Then about uncertainty, the biggest result is that none of them actually knew about this categorization, these differences, these nuances of uncertainty in science. And they actually realized, they told us many times, like now my image of physics, my image of science is broader. It's like something that is more large. Now I can actually understand that there are many aspects of science. Science is not just numbers, not just equation. And that was really interesting. And also, like they use phrases like, I was also fascinated by like this openness, and it was a point of view that maybe I didn't know before. So it's like, it was really an interesting approach. But like today I'm focusing like more on the extreme events part, but also that there is a lot to talk about how they perceived uncertainty. So maybe we can do that like later. And then the main result that came from the game mostly was the relation between the policy making. So like they basically, were like in the, let's say, in the leading role, like in the game. So they had to make decisions to change the future. So they were feeling as they were the policymakers, okay? And it was really interesting to see that, just the game, changed my, my vision completely. It helped me to understand that in the end, these areas like science and politics are much more connected than I thought. And also this perspective taking. So like they were, okay, so maybe before the course, I thought that politicians were, people that were not caring at all about the problem. So they were only acting on their own, like the greediness. But now I actually understand that it's really complex. It's really difficult to make decisions that can actually help people. Because a really interesting result of the gameplay was that they almost all of them achieved the goals. So like to have a temperature, like lower than 2 degrees, like a sea level rise under 60 centimeters. That was like the target we gave them. But to reach the goal, they basically worked on this slider here in particular, the carbon price. Okay, so like the platform gives you the possibility to change the taxation of like the carbon production. And now I don't have like the specific, but the lower end, like the left hand, was $4 per ton of CO2 produced, while the higher hand was 250. All right. So they noticed that working on that slider, like there was like a big change. Okay, I can show that later. But it was like falling like just 1 degree, only acting on that. So basically, all the groups worked on that slider in particular. They put all the budget they had on the carbon price. At one point, we then asked them, all right, so what kind of future did you create? I mean, like you reached your goal, but what kind of future would you like to live in this future? And they started to realize the impact of that decision, and they were like, okay, we actually reached the goal, but I don't think I would like to live there, because it's just a word for like the richest, it's a word for the more wealthy people, and it's a really like it's a word where there isn't like no equality, and all the people, many people were like left behind. And this was really interesting because they didn't thought about the consequences of their action while playing the game. So we had to ask them what kind of future you built. So they said, okay, it's really complex, like to make this kind of decisions. Just like so easy. It's just let's go green. We need to take into account many different aspects, many different areas. Okay, so the main evidences from this data is that like we saw like this different kind of results. So mostly when they think about climate change, they think about extreme events, and extreme events can be seen as something that like is a powerful instrument, like to tackle the problem. They also realized that their previous perception of climate change was in some sense naive or incomplete. And they appreciated like this course in showing them different dimensions of the issue. They appreciated a lot the kind of scenario representation, both the one that was created by IPCC, also the one that was that actually they went through, We also, during the course, talked about the kind of narratives around future. So like the whole solar punk approach, you like to actually think about positive futures, like to introduce some sort of hope. And also students admitted that their perception of the role in addressing the issue changed slightly. And this is interesting because when they actually discovered the bigger like complexity, so when they went a level after the naive vision, they actually, some of them were like more prone to implement change in their own life. So like, okay, now I know what's the issue, so I know what kind of things I need to do. While other are like, all right, so now I know how big is the problem, and I feel hopeless. I feel more hopeless now than I was before. I feel more powerless. Some of them reacted in this way. And I think it's natural at one point, but it's something that we need to address because we don't want, them to leave the course with the feeling that there is no hope. So, like this is like something we should work on. And then we called the whole process of like the perspective taken towards policymakers as like a reality shock. So like, to actually understand that things are way more complex than you think they are. And it's not just so easy. So like understanding the proper, like I was talking about yesterday with the colleague here, like to be a realist, like to actually understand like what is the reality behind it. And that was really interesting. So in the last months, as I said, I worked with an expert from disaster education. So we focused on how extreme events can actually be used to enter like more in the discussion, to also open their, the more like, let's say, personal part. So we started to use this concept as the psychological distance. I don't know if you ever heard of it. So like distinguishing between different levels of distance toward the issue that could be like in the future, could be like in another place, far from you, can maybe affect other people. So maybe focusing on extreme events and focusing in particular on disasters could be a possible way to make them feel closer without having them, go through like a disaster, in the first experience. But it could be like a really interesting way to make them realize the severity. So like focusing more on the role of extreme events. And it also like could be really an interesting starting point to basically work on the whole attribution thing. Because also another thing is that they were attributing all of the kinds of extreme events to climate change, even like a heavy rain. It was all of climate change for them. And this could be an issue connected to the whole concept of actually trusting scientists and actually understanding what are the layers of like, the science behind it. This would be very interesting. So like the idea would be to add also the whole like disaster education like area to this like prism of all the dimensions of my work, but still like in the making. So we'll see. And on this, we actually, like we're still working together to understand how extreme events can actually give us main information about how to tackle climate change, also in different environments. Because of course, when we talk about like the Italy framework, it's not that rare because it's happening often and often. But there are other parts of the world where this kind of events are already happening. They're already happening. They happened like many years ago now. So it's something that we need to discuss now. So like bringing disasters in the classroom for like a different, like multiple perspective would be like a really useful tool. And this could be like some sort of hypothetical new approach. So like something that I'm still working on. So instead of using, just giving them the vision of uncertainties in physics and then going through extreme events, starting from extreme events and then focusing also on like the personal experiences to like lower the distance toward the issue. And from that opening to the whole, how science actually addresses this kind of issue and what kind of uncertainties there are, climate studies, and also to open a proper discussion on the natural science and also the trust in science, because we need to address climate skepticism. And from there, moving on to the scenario makers and future studies, so like also the game, but also focusing on what are the possible things that we could do. So like showing them examples of like local action and proper activities that are maybe made like in a regional area to work on the problem, trying to avoid the hopelessness, feeling. So there are many open questions, of course, because like it's just a PhD project. So there are like many things that I would like to continue on. In particular, some questions that we can discuss maybe together now, or like whatever kind of questions we would like to answer that. So maybe in what way we can actually help students create proactive and yet realistic visions of future. So like some sort of active hope, but grounded, not just hope for like a better world. Also, which indicators and tools can be used to measure like sustainability competencies, so like to see the effect of the course, maybe like also on a longer distance after like 6 months, 1 year after the course, what kind of things. What possible further dimensions can be added to the theoretical framework, to make it like suitable also for like non-physics teachers. Because I think we would like to do now is to make more iterations of this course with different colleagues, like around like Bologna, but also like in other places in the world. Many people were interested like in the game, when I presented like in this months. So it could be really interesting. And of course, climate change is like so interdisciplinary that would be like so interesting to have like many people working on it. So we're thinking about that. And also, what kind of space can be occupied within the school curriculum? I mean, like who's gonna like teach this? Because it takes like a long time to work on these aspects. So how to connect this like external course to things that are meant to be like in school. I don't know, it's like really open, and I hope I will be like I was clear enough. So these are like some references, and thank you for listening. So and just last thing, I will finish my PhD December this year, so I'm almost there. And after this, hopefully I'll continue like I don't know where, but hopefully like I will be like able to continue. Yeah. So yeah.
Wonderful. Thanks very much. Thank you. So I was just going to say there is a question online. I think we're just finding it there. Have you got the question?
Oh, I've
If not, then
activated the chat, so people should have access to the chat now. You just have to, well, yeah, you can send questions to the chat, or you can change the 2 hosts and panelists to everyone if you want everyone to see your chat. But I'll also put the question feature.
Can you check the permissions for the chat? Is it everybody can see?
Yeah.
So attendees. Okay, can you do panelists?
Yeah.
Okay. And then Bill, do you want to read out the first question?
Yes, so we've got question came in quite early in your presentation. And I wonder, did you study physics as an undergraduate as well?
Oh yeah, I didn't explain that. Yeah, I started with physics and then physics education.
Right. So the question from Martin Braun is, what is your opinion on how to effectively embed sustainability in traditional higher education physics? So again, you were looking in your project more in secondary education, but also you have experience higher. I'm curious.
This is really interesting because usually like the physics curriculum is really focused, at least like I'm talking for the Bologna experience because it's the course I did. It's really focused on like the like classical part of physics. So like you have to go through mechanics, thermodynamics, all these kind of things. And talking about sustainability, I think is something that comes up later in the curriculum. I think there is a lot of space actually because like physics can open to a lot of discussions. Maybe talking about like the process of like clean energy, or like how the whole connection with the, as I was saying before, like the connection with the policy level can actually be interesting because there are many physicists that are actually working towards these kind of things. There is a whole discussion that could be made on the sustainability of like quantum technologies, or also like data mining. There are many aspects that could be talked about. And those something like physics is just so general that can be connected to almost everything. So like, we have like many discussions about the whole, Oppenheimer phenomenon. So like, when science can actually change completely, the world. So like the sustainability of the research behind it, and why do we need like to go into space, like to create like this, huge shuttles just to go on with our kind of knowledge. So there is a lot of space for that, and it depends also on the background, of course, on the people. And I think this is like something that I feel really deep. It should start also always with the needs from the students. I mean, like there is a lot of space, many things we can talk about, but I think it should start like from the students, so like from their curiosity to understand how the things they study is actually connected to the things they do in their life. So yeah.
And a very practical follow-up on that, how did you get access to so much time of the students? If it was 3-hour sessions and 6 sessions, that's quite a time commitment. Was that through a physics class? And
as I was saying,
during the whole day?
Yeah, basically in Italy, students in high school must attend, I think, a total amount of 90 hours in the 3rd, 4th, and 5th year of activities that are also in the school. Usually that could be like, work related or university related. So it's more like formation. And universities in the system is called PLS. So it's like the scientific degree plan. We offer like many opportunities, many courses for them to fulfill. And usually they're like 20, 25 hours, depends on the kind of things. And the Department of Physics in the University of Bologna gives many courses like quantum technologies, I don't know, like more scientific based or like more social based, but there are many opportunities. So maybe students had to, go on with these hours. And some of them chose to come to us for the climate change, because, it was connected to climate change. Some of them were just curious about physics, because, they wanted to like start physics in some months, so they wanted to come. And others just came because they had to, because, like it was that first opportunity. And it was like really interesting to see the reactions of students between different possibilities, let's say. Yes.
So there's a couple kind of practical type questions. So I'll ask both of those at once and you can answer.
Okay, yes.
So Sule Akuyunu asked about if there's a website for the course.
Okay.
And then to ask you one more about the research question, Sarah Caron asked about assessing their understanding or background of climate change kind of pre and post. You mentioned a little bit about kind of some of the surveys and questionnaires you used, but kind of is more of a question of, did you consider assessments prior to the development of the course to understand the student's background in climate change?
Okay, so for the website, there is a presentation of the course, but like we're actually working on now on the, like publication of the articles connected to it. So like in some months, there should be something already like, I'm gonna present this in a couple of conferences this summer. And also we have like a couple of special issues connected to this. So maybe in some months, there will be possibility like to read more broadly about this. For the questionnaires, it was just, everything was almost last minute because we had to work a lot on, many struggles, but we created a questionnaire that had like some open questions, are like the ones you saw now, I showed before. And also other questions connected to their own perception of sustainability competencies. So like, how do you write like, the importance like this issue rather than this other issue? And we focused on those questions to work on the, like also for the interviews, like, to navigate the interview. It wasn't a proper assessment because we couldn't, like reach them before the course. And we had to like, go on with it like during the course. So like, depending on what kind of activities we were doing, we also like shaping the rest of the course. So for sure, the next time we'll try like to actually understand what are the effects on the understanding of climate change basics, because that's also really important. But yeah, this time there wasn't like a proper like assessment or like their knowledge and competences about it. And that's why I wanted to like to see if there are like some tools, because like it's really hard, of course, to make an assessment tool for competences, because you cannot assess a proper competence. You can assess knowledge, but we didn't just want to give them just fill the box or whatever. So yeah, maybe next time we'll, like there is space like to find a proper tool to do that. Yes, depending also like on the people you work with. Yes.
And then there's a couple more questions that are slightly bigger picture. So
Right.
one is on this question of uncertainty, and then the other is on student activism. So
Okay.
Dan Koppel asked, I'm interested in your focus on uncertainty. Do you feel like most pupils in your study had quite inaccurate fixed views on physics? For example, as a body of knowledge rather than an inquiry with problem solving, etc. And then on the activism side, Chris Taylor, who was from France, what do you think of the role of encouraging student activism and promoting a positive approach which can reduce climate anxiety, such as class writing letters to IPC scientists, hot delegates, or students attending the climate struggles?
Okay, this is really interesting. Thank you for the questions, though. So for the first one, it was really interesting to see the reaction of the students because it was like plenty of moments where we have like, all discussion. It wasn't just, lecturing, it was just, like talking about it. And this was like the first big difference for them because usually there isn't that much of a space for like discussion in a science class. So most of them, like during the interviews, they said, like usually in a school, we don't have like space for, for talking, for like sharing, like how we feel about something. So this is really interesting, like to give this kind of space. About physics in particular, they actually had like more closed, let's say, vision of what physics was. Some students were actually not really happy with the course because they were actually expecting, the classical standard view of physics, like we wanted like more equations, like we wanted more theory. So they were like really happy with the first part of the course when we focused on uncertainties in physics because we described, like the quantum theory, the complex systems approach in physics, and they were like really happy with that. But then when we moved on like to the more, like say, social, aspects of science, they were like, I don't want this, I want like the hard part, but like just 3 or 4. But all the rest were like really happy in seeing that science can actually be, can be so open. And that, physics in particular, but of course I talk about physics as I come from physics, but this can be actually, applied to all scientific disciplines. They are so connected and so interesting, like, to discuss from a scientific perspective, a social issue, or like coming from social issues, like to talk about scientific problem. I think there is the need like to merge more because there is always like this, classical vision, and this vision is gonna end up like, change their future. Because if I have like a certain vision of what physics is, maybe I will not fulfill, like a physics course. So many of them were like, I would like to go to engineer, but because physics seems like too theoretical, like physics seems like too Christian, like, there is space, it's just different. So giving them this opportunity was really nice for them. About the second question, I think that everybody like should be an activist in some way. So like it's really interesting to talk about these issues and to basically start from their ideas, because sometimes students are asking, in the literature, it's really, we know this, students ask for knowledge about climate change. So it's really important to address these issues and not just to be, like to go on and talk about other stuff, because maybe it can be like, a political problem, like it can be really difficult to talk about it. But I was like attending a conference in Copenhagen last week about environmental humanities. So like addressing environmental issues like from a humanity perspective. And they were saying, everybody needs to be an activist when we are teaching, because we need to give them possibility like to speak, to act, and to work on these issues. And it's really interesting also to focus on how climate activism groups can, how they gain their knowledge, what kind of scientific process there is behind climate activism, because it's really broad. I mean, like they actually have a lot of like big network and they want to learn more. So opening to activists can be a really a good opportunity for everybody, like to give them like more nuances of like the scientific process behind it and to actually understand the vision. So like to connect on this level, I think it's really necessary. And there was also something on.
Yeah, there's one other question around adapting this to adult learners.
Okay.
As in these questions, in terms of how we engage with uncertainty, or people, not 100% sure about how to connect the dots between the scientific process and policy.
Yeah.
That can happen later.
Yeah. As well. I think that I think that to address the more adult public, could be really interesting to focus on the local perspective, like to present the global framework, but to give them more information, for example, on local activities. Like, students are not yet able to vote. Like the people we had were almost there, but they didn't have like a proper picture of what politics is. But adults, they have, no. So this, mistrust towards the political class, it's really something that is there, and we need to address it. So maybe focusing more on why it's important, and also what are the examples, like the things that are being done, and what they can actually do. Because the more like adults have like usually more power, towards the issue. So I think it's really could be very interesting. And then depending on the people you have like in front of you, changing also the kind of knowledge you want to give them, So maybe something that is more like broader, not just physics. Maybe you don't talk about quantum theory, but maybe you talk about like other, sides of science. There is like so much space like to go around it. So yeah, it'd be really interesting.
Yeah, so no other questions online, and we can continue the conversation, but does anybody else want to, in the last couple minutes, ask anything from the room? So I have a question about the game that you
Okay,
use,
yes.
because I've come across En-ROADS, the
Yes.
MIT simulator,
Yeah.
and have wondered about how to apply it to some of the things
Mhm.
we're doing with undergraduates here, and so then I thought it was interesting that you developed a whole other layer on top of it.
Yeah.
And because I also, as I understand it, they offer their own resources for how to use En-ROADS, and so why was it that it felt like this kind of gamification of something already interactive was necessary for your project?
I think that we saw all the activities that they do, and they are really connected to the like the policy level. Like it was almost similar because you can work in the future and see what other things. The main problem for us was to give them a tool to properly represent a future scenario. So like the whole representation was like a big part, because from like our other projects that we did as a research group before, or they did before I arrived, I don't want to take the credit. So like the IC project, the Fedora project, there was this problem of properly envisioning future, So we wanted to give them something, practical to do, and we came up with the idea of creating this sort of map. Because basically I didn't explain this, so they have to starting from the center, they had to maybe create like some lines, and there's like much to say about this game, but every small line is connected to a percentage of the slider. So depending on how much they wanted to go from one side to the other, they could move along and like trace, create a line. And that line was representing the kind of idea they had about it. And we thought it could be interesting because also we wanted to add the whole uncertainty layer, and there wasn't in the activities that MIT gave. So we wanted like to give it a personal, like some more like connected to what we were saying about, because it wasn't like the activity, they're really great, but they focus a lot on the decision making. Imagine like you're a scientist, these kind of things. It was like a bit far, so we wanted to create something that could merge, and it's really interesting. Like there is a lot to talk about. Yeah.
Oh, that's great.
Oh, thank you.
Thank you very much.
Fantastic. Thanks very much, and thanks very much joining us online and in person. If people are sticking around, then there's some kind of food and refreshments and stuff. And otherwise, just to say that an upcoming ETC Hub webinar, date for your diary, the 21st of June, will be joined by some colleagues, including colleagues from UCL. So you can get that in your diaries, and there'll be more information coming out soon. Otherwise, thank you very much.